Important conversion reactions in organic chemistry. Firstly, let me teach you 4 important conversion reactions in less than a minute. We know that oxidation is the gain of oxygen, while reduction, being opposite, is the gain of hydrogen. Whenever we oxidize any reaction, we add oxidizing agent to it, like potassium dichromate. It will oxidize the reactants. Secondly, whenever we reduce any reaction, we add reducing agent to it, like lithium aluminium hydride. It will reduce the reactants. Now let me ask you, convert alcohol to aldehyde and aldehyde to carboxylic acid. Secondly, convert carboxylic acid to aldehyde and aldehyde to alcohol. Well, the easy method is to oxidize them. Consider ethanol. I oxidize it and it will convert to ethanol. I oxidize ethanol and it will convert to ethanoic acid. On the other hand, consider this ethanoic acid. When I reduce it, it will convert to ethanol. When I reduce ethanol, it will convert to alcohol. Thus remember that if we oxidize alcohol, it will convert to aldehyde. If we oxidize aldehyde, it will convert to carboxylic acid. On the other hand, if we reduce carboxylic acid, it will convert to aldehyde. If we reduce aldehyde, it will convert to alcohol. Also note down this very important conversion reaction, which I will use too often in this lecture. Consider alkyl halide. When I add aqueous potassium hydroxide to it, it will convert to alcohol. For example, consider this alkyl halide. I add aqueous potassium hydroxide to it. We get ethanol. Hence remember these basic conversion reactions. Now let me teach you important conversion reactions of increasing carbon atoms. In such type of conversion reactions, the number of carbon increases from 1 to 2, 2 to 3 and 3 to 4. We use 2 reactions to do these conversions. One is Wurtz reaction and the second one is Corey-House reaction. In Wurtz reaction, we convert single carbon atom to 2 other carbon atoms. Remember that we always add sodium and ether. In Corey-House reaction, we convert 2 carbons to 3 carbons. Remember that we always add copper iodide, lithium and methyl chloride in it. In other words, we use Wurtz reaction to get even carbon numbers, while we use Corey-House reaction to get odd number of carbons. For example, convert methane to butane. We know that CH4 is less reactive. Firstly, we have to activate it. In order to activate it, we always add chlorine and UV light to it. We get alkyl halide. Now according to Wurtz reaction, we can convert this CH3 to 2 carbons. Hence I add sodium plus ether to it. I get ethane. Now this ethane is also very less reactive. I activate it. I add chlorine plus UV light to it. I get ethyl chloride. According to Wurtz reaction, we can double these 2 carbons. I add sodium and ether. I get butane. Hence I convert CH4 to alkyl halide, to ethane, to ethyl chloride and to butane. Secondly, convert methane to propane. I activate CH4. I add chlorine plus UV light. I get methyl chloride. Now I want to double this single carbon. I use Wurtz reaction. I add sodium plus ether. I get ethane. I activate this ethane. I add UV light. I get ethyl chloride. Now listen carefully. There are already 2 carbons. I need to add only 1 carbon to it. Hence I use Corey-House reaction. I add copper iodide, lithium and methyl chloride. I get propane. Thus I converted CH4 to methyl chloride, to ethane, to ethyl chloride and then using Corey-House reaction, I convert it to propane. Therefore, using Wurtz reaction and Corey-House reaction, we can easily solve conversion reactions of increasing carbon numbers. Now the second type of conversion reactions are decreasing carbon atoms. In such type of conversions, the number of carbon atoms decreases, like 3 to 2 or 2 to 1. Here, remember this important conversion, which I will use. If we add soda lime to carboxylic acid, it will convert to alkane, but the alkane will have one carbon less than the total carbons in carboxylic acid. Here, let's convert propane to ethane. We know that we will use these steps. Firstly, we will activate propane by converting it to alkyl halide, then to alcohol, to aldehyde, to carboxylic acid, and then to alkane. Now I add chlorine plus UV light to it. I get propyl chloride. Secondly, we have to convert alkyl halide to alcohol. Can you recall the conversion of alkyl halide to alcohol? Well, we add aqueous potassium hydroxide to it. We get propanol. We already know that we oxidize alcohol to convert it to aldehyde, then to carboxylic acid. I add oxidizing agent to alcohol. I get propanol. I add oxidizing agent to it. I get propanoic acid. Now according to this conversion, if we add soda lime to carboxylic acid, we get alkane having one carbon less than carboxylic acid. Thus I add soda lime or mixture of sodium hydroxide and calcium hydroxide. Now there are 3 carbons in propanoic acid. I get alkane which has only 2 carbons. Hence this is ethane. Therefore, using these steps, we can downgrade the number of carbons in any alkane like converting propane to ethane. Now the third type of conversion reactions are bond conversion. In these type of reactions, we convert bonds like single to double, double to triple, and vice versa. For instance, in case of single bond, we do its dehydrohalogenation. The word dehydrohalogenation means that we remove hydrogen and chlorine atoms. To do so, we add alcoholic potassium hydroxide and we get double bond. In case of double bond, we add sodium amide to it. We get triple bond. In opposite case, we can convert triple bond to double bond and double bond to single bond by reducing them. In order to reduce them, we just add nickel plus hydrogen to it. Hence noted down these important conversion. Now consider these conversions. Convert ethane to ethene, ethene to ethine, or ethine to ethane. Firstly, I write here ethane and I activate it. I add chlorine and UV light to it. I get ethyl chloride. Now I add alcoholic potassium hydroxide to it in order to do its dehydrohalogenation. I mean, I remove hydrogen and chlorine from it. I get ethene. In this case, I write here ethene. I activate it. Now I will add sodium amide to it. I get ethine. On the other hand, I write ethine here. I reduce it by adding nickel plus hydrogen. I get CH2 double bond CH2. Again I add nickel plus hydrogen to it. I get ethane. Therefore, using these simple conversions, we can easily do single bond and triple bond conversions. Now I will teach you some important conversion which you must learn. Convert alcohol to amine and amine to alcohol. Well, to convert alcohol to amine, we use Lucas reagent like HCl plus zinc chloride. For example, consider this alcohol. I add HCl plus zinc chloride to it. I get alkyl halide. Now I add ammonia to it. I get this amine. Thus remember that using Lucas reagent, we can convert alcohol to alkyl halide and then using ammonia, we convert alkyl halide to amine. On the other hand, convert amine to alcohol. We use nitrous acid, HNO2, to convert amine to alcohol. For example, consider this amine. I add nitrous acid to it. I get alcohol. Thus remember that using nitrous acid, we can convert amine to alcohol. Secondly, convert amide to amine and amine to amide. Well, this amide always reminds me Hofmann-Brom-amide reaction. Let me repeat it. This amide always reminds me Hofmann-Brom-amide reaction. We use bromine plus potassium hydroxide in Hofmann reaction. For example, consider this amide. I add bromine plus potassium hydroxide to it. I get this amine. In case of amine to amide, I follow these steps. We can easily convert carboxylic acid to ammonium salt by adding NH3 to it. Later, when we heat the ammonium salt, we get amide. So I will convert this amine to alcohol. We have already learned that if we add nitrous acid to amine, it will convert to alcohol. Now I will oxidize alcohol to get aldehyde. Also, I will oxidize aldehyde to get carboxylic acid. Now according to these steps, I add NH3 to carboxylic acid. I get a salt of ammonium. I heat this salt of ammonium. I get this amide. Thus we convert bromide to amine if we add Hofmann-Brom-amide reagent to it. Secondly, we convert amine to alcohol, then to aldehyde, to carboxylic acid. We add NH3 to carboxylic acid to get the salt. When we heat the salt, we get amide. So note it down all these important steps. Lastly, convert nitro to amine and amine to nitro. In case of nitro to amine, we reduce nitro in order to get amine. We have already learned that lithium aluminium hydride is the reducing agent. For example, consider this nitro. I add lithium aluminium hydride to it. I get this amine. In case of amine to nitro, remember these steps. If we reduce alcohol by adding hydrogen iodide plus red phosphorus, we get alkane. Later, when we add fuming nitric acid to alkane, it will directly convert to nitro. For example, I take this amine. I add nitrous acid HNO2 to it. I get this alcohol. Now according to these steps, I reduce alcohol by adding hydrogen iodide plus red phosphorus. I get alkane. I add fuming nitric acid to it. I get nitro. Thus remember that if we add reducing agent to nitro, we get amine. Secondly, we convert amine to alcohol, alcohol to alkane, and alkane to nitro. Now you must note it down all these important reactions on a chart. Try to recall and practice all these conversions for a week. By practicing and revising, you will master all these conversions. Thus note it down all these important conversions. Lastly, let me teach you some exam questions. For example, convert propanol to ethine. Well, this is propanol and this is ethine. We can see that there are 3 carbons in propanol and there are 2 carbons present in ethine. Secondly, we will convert alcohol to alkyne. Now you should carefully observe these steps which I will follow to convert propanol to ethine. I will form a strategy. According to that particular strategy, I will follow each and every step. Firstly, I will convert alcohol to aldehyde and to carboxylic acid. Now I will break carboxylic acid to get ethine. Then I will convert ethine to ethene and to ethine. For example, I write here propanol. I oxidize it to aldehyde. I oxidize aldehyde to carboxylic acid. I add soda lime to carboxylic acid to break it to ethane. I activate ethane to ethyl chloride. Now I will do dehydrohalogenation of ethyl chloride. I add alcoholic potassium hydroxide. I get ethene. I activate ethene. I add sodium amide to it. I get ethine. Thus, using these steps or this strategy, we can easily convert propanol to ethine. Lastly, convert propamine to ethanol. Well, this is propamine and this is ethanol. We can see that there are 3 carbons present in amine and 2 carbons are present in ethanol. Secondly, we will convert amine to aldehyde. I will follow this strategy. Firstly, I will convert amine to alcohol, to aldehyde, to carboxylic acid. I will break carboxylic acid to ethane. I will convert ethane to alcohol and then to aldehyde. For example, I write here propamine. I add nitrous acid HNO2 to it. I get propanol. I oxidize it. I get propanol. I oxidize it. I get propanoic acid. Now I will break down propanoic acid to ethane. I add soda lime to it. I get ethane. I activate ethane. I get ethyl chloride. I add potassium hydroxide to it. I get ethanol. Lastly, I oxidize ethanol. I get ethanol. Therefore, using these steps, we will easily convert propamine to ethanol. Thus, noted down all these important conversions of organic chemistry.